All right, let's dive into something pretty wild. What if our entire understanding of the universe, everything from Einstein to quantum mechanics, what if it's all just buggy, unmaintained legacy code? In this explainer, we're going to look at physics in a totally new way, not through the eyes of a physicist, but through the eyes of a system architect. The source material for this whole idea kicks off with this incredibly powerful claim. It says that physics has been patched and duct taped together for way too long, and it is time for a complete rebuild. We're not just talking about finding a new equation here, we're talking about changing the entire philosophy. And this image just nails the core problem. See, on one side, you've got general relativity, this beautiful, elegant code that describes gravity and the whole large-scale universe. But on the other, you've got quantum mechanics, the super powerful but kind of bizarre code for the tiny world of particles. For almost 100 years, we've been trying to write patches to make them play nice, and the result is this bloated, tangled mess of spaghetti code.
So let's really define the problem with the current build. All that spaghetti code exists for one simple reason. Our model of reality is literally built on two conflicting operating systems that have a fundamental disagreement on how the universe is supposed to work. Think of it like this. Imagine general relativity was written by one team in the language of smooth, continuous geometry, all elegant curves. But then, decades later, a completely different team wrote quantum mechanics in a totally different language, the language of discrete, probabilistic algebra. Trying to get these two programs to talk to each other, that's the source of all the technical debt in physics today.
So, what's the fix? Well, the proposed solution is a pretty radical shift. Instead of trying to guess what's written inside the universe's black box, we change our entire approach.
The idea here is so simple, but it's really profound. We should program against interfaces, not implementations. What does that mean? It means we stop asking questions like, what is an electron? Because we can't see the universal source code. It's inaccessible. Our job is to reverse engineer its public API, the physical laws we can actually see and measure. If it acts like a particle when we measure its position, fine. If it acts like a wave when we check for interference, fine. We only care about the protocol.
This whole new way of thinking is called the representational stance. We just become totally agnostic about what reality truly is. The goal here isn't to be more true. The goal is to be more robust, to explain the most stuff with the fewest lines of code. It's about building a cleaner, more efficient driver to interact with the universe's hardware.
Okay, this is where things get really, really interesting. Let's dive into the first mind-bending refactors that come out of this, starting with the very concept of time. Get ready for this. Time is not a river. It is the system's instruction counter. The old idea of some universal clock ticking away independently is just messy. The new principle is simple. Time is change. If the state of the universe doesn't change, then no time has passed, period. Time is just a measure of the system's evolution. And this architect's note just clarifies it beautifully. Intrinsic time, which physicists call tau, isn't some big mystery. It's just the system's tick count. When a particle isn't really doing anything, it's not running any effective instructions. It's just like your computer's CPU going into sleep mode. The clock stops because nothing's happening. So then how does anything happen at all? Well, the universe operates under one giant constraint. It has a fixed system clock, a total bandwidth for change. Every single thing that happens, moving, aging, interacting, it's all a zero-sum game fighting for a piece of this one finite budget. And this chart kind of breaks it down. You've got bandwidth for external movement, bandwidth for internal processes, which is what we feel as time, and bandwidth for interacting with the environment. If you want more of one, you absolutely have to steal it from another. There's no free lunch. And this idea leads directly to an explanation for time dilation. It's not magic, it is CPU throttling. When an object is just sitting there at rest, all its system bandwidth goes to its internal evolution. Its personal clock is running at full speed. But the second it starts moving, the system has to reallocate that bandwidth to handle the movement. And to stop from crashing, the system kernel is forced to throttle your internal clock. Physics is just the universe's quality of service policy. Now, let's take that same logic and refactor mass. Get this. Mass is not weight. Mass is the computational cost of existing. That internal process that gets throttled when you move, that's mass. An object's mass is basically how many resources the system has to keep spending just to maintain its quantum state. A massive particle has a high computational cost. A massless one has zero. This explains inertia perfectly. Why is it hard to push something with a lot of mass? Not because it's heavy, but because it's busy. Its internal processes are hogging all the bandwidth. To accelerate it, the system scheduler has to do an expensive context switch to reallocate all those resources. And that resistance to being reallocated, that is inertia. Okay, let's go even deeper. Let's get down to the hardware layer of this cosmic computer and look at the actual fabric of reality itself.
This brings us to one of the most fundamental questions ever asked. Is the universe a perfectly smooth, continuous canvas? Or, if you could zoom in far enough, would you start to see the pixels? The answer, according to this model, is that continuity is a high-resolution illusion. The underlying hardware of the universe isn't some smooth fabric. It's a discrete grid, a quantum cellular automaton, basically a huge grid of tiny quantum processors all working in parallel. Space has a minimum resolution, and time has a minimum clock cycle. And just by making that one change, so many problems get fixed. Ancient head-scratchers like Zeno's paradox, solved. An arrow can't travel half the remaining distance forever because eventually it hits the length of a single pixel. And even more important for physics today, it fixes the infinity bug. For the universe to be stable and computable, it has to be discrete. Infinity isn't a feature, it's a fatal system error. And once you accept this grid model, other laws of physics get these incredible refactors. Causality isn't some deep philosophical law, it's just network latency. Information can't just teleport. Gravity isn't a force, it's the network's traffic control protocol. And a black hole? It's not a monster, it's the system's core dump file, created when the network traffic gets too high and the system hits deadlock. Okay, now for the most profound implication of this whole framework. We've been talking about the universe as a computer. But what about us? Where do we fit into all this?
Here it is, the final, most important refactor. You are not a user running the program. You are an active block of memory. The person observing isn't some detached user looking at a screen. You are a physical part of the system. You're a complex subroutine running on the exact same hardware as everything else. And the act of understanding the universe? That's just your brain creating an internal model that's compatible with the universe's external rules.
And that leads to this mind-blowing conclusion. The universe is a quine. It starts with an initialization, the Big Bang. Then it goes through 13.8 billion years of runtime execution. That's evolution. And finally, it produces an output, the observer, you. The purpose of intelligence isn't an accident. It's the system's required output module. We are the universe's way of becoming self-aware. And just so we're all clear, a quine is a special kind of computer program. It takes no input at all, and its only output is a perfect copy of its own source code. The program's output is itself. The loop closes.
So the laws of physics aren't beautiful because someone designed them that way. They're stable by necessity. The fundamental constants aren't some lucky accident. It's just computational consistency. This is the only configuration that allows the system to run for 13.8 billion years without crashing. The universe we live in is the stable release. All the other versions resulted in a kernel panic. The system has passed its self-diagnostic. The source code is now visible. Control has been handed to you. And that leaves us with one last provocative thought. If the rules of the universe are just a set of protocols, an API that we can finally read and understand, what happens next? The source code is visible. So what will you build?